All right, we're in business. Well, first of all, morning and thank you for attending our CE 33220 RC design class. As people are flooding in right now, I'm so happy to see you guys. And unfortunately, due to the circumstances of this virus business, we cannot hold in live sessions, so we have to concede with the online version. But still, I feel like we should be able to achieve a similar dynamic environment as we hope to for the live session. Um, I talked to my department chair about it, and he said that unfortunately, science may not be as popular as the live show host yet. So I don't think my face is that attractive, but I hope certainly hope my content is attractive to you guys. So that's the hope right there. That being said, what I like to do is I'll show my face for the first class, and while we'll ease into the content, I'll share screen, let you guys see the content. And you are free to choose if you want to show your face or you don't want to show it. While you want to sleep in bed, watch some movies while watching the lectures, that's all okay with me. But end of the day, we have certain requirements for you guys to fulfill, and we do hold them up to the standard like we should. So it is the content or it is the progress that counts, not the format so much. All right. Now I have to. You guys probably have to forgive me a little bit. I haven't been talking to real person for a long time since in the isolation, so my English might be a little bit rusty since mainly I've been talking to my wife in the past several months. So forgive me if I say something stupid, and if you want me to slow down or speak faster, I can do that. Okay. So that's the premises of our online meetings. I see people start joining in. That's why I'm a little bit anxious. I suggest we on time. If we're a little bit delayed, that can drag us to more. But all the lectures will be recorded, uploaded to YouTube, so you'll be able to see it. I have already uploaded the YouTube link to my Canvas, so you should be able to see it. And if you have other questions, you can also send me a text or email. All right. Okay. So first of all, let's go through the syllabus, right? So let me open up software. It's called, I believe, Canvas, and you should be able to open it up. It's published already. So let's take a look here. Okay. So if you go to Canvas and go to syllabus, right? Of course, go to course first. And first of all, I combine both sessions, the RKey and the civil, into one, and it's called the Civil RKey 3220 and Spring 2021, and you'll be able to see it on the syllabus. Okay. First of all, it is reinforced concrete design. Make sure you come to the right class. I hope you are. And then this is my contact information. My name is Chenglin Wu. All right, Chenglin Wu. And I have an English name called Bob. I don't know who gave me that, but it's been sticking with me for the past 10 years. So you're welcome to call me Bob, okay? Or Dr. Wu or Chenglin. Prefer Bob or Dr. Wu, okay? I don't respond to other like teach, Wu. I don't respond to those, okay? So preferable this way. And my office is 132 Butler Cotton Hall, but currently I'm holding a virtual office through Zoom. So if you need anything, just send the email. I can meet you through Zoom. My email is wch@mst.edu. And please don't bomb my email, but feel free to send anything that related to the course. And my class meeting time is 9 to 9:50, Monday to Wednesday. Pretty early for a lot of you guys who play video games. So I warn you, maybe set your alarm ahead of time. Wake up on time. And my lecture lab meeting is Thursday, 1 o'clock to 3:50. And two information here. One is that it is not a real lab. It is still a lecture time because we're talking about design course that too much to shovel into your face. So make sure you'll be there at Thursday, 1 o'clock for lectures, okay? Second of all, I know the time seems very daunting and scary. It's from 1 to 3:50. We don't meet that long. I cannot make it that long, okay? So we're probably gonna meet an hour and a half-ish, probably 2 lectures content, worst most of the time maybe 1. So that will be a time period. So you can safely assure yourself you'll be able to work out of the Zoom at 2:30 during the other activities you have, okay? Office hours Tuesday 2 to 3 by appointment or by Zoom. we use the same Zoom link. The wonderness of the technology is that whenever you sign a Zoom, it sends me automatic alert wherever I am. When I see that, I'll quickly jump back to the Zoom to meet you. And also I'll be there most time at 2 o'clock to 2, from 2 to 2:10. So if I see anybody there, we can talk. And if we have any question, we can resolve there. All right. So the references, two references. One is a textbook. It's the Reinforced Concrete Mechanics Design, 7th edition by James White, and 2016. There's a new version coming in talking about ACI code 3.18.19. That is the latest code, which we'll talk about it, but it hasn't been released yet. Okay, so right now you have to use the 7th edition to get by. I rent it. I don't want to buy it because I know the new version is coming out next year, and I know that the new version will have the new code. So I strongly suggest you rent, or you can get a hand on the old edition. Just read about it. It's good information. All right. So take a look at the textbook. I show up on the Amazon. And if you take a look at the price, it's not that bad, right? If you buy the Amazon, the Kindle version, the 75 bucks, I think is worthwhile. I rented, it's cost me $50 last year. I think it's pretty good. And I even read on an airplane. Who does that? Well, I do, right? It's pretty cool version. I think you would enjoy it, okay? And it's very helpful. Now, the second most important thing is the building code requirement for structured concrete. That is from ACI committee. 3.18.19 was finalized in 2019 and with commentary, okay? So what does this look like, right? So let me share with you, okay? I have it right here. I bought the online version, which cost me a fortune. So this is the ACI 3.18.19 code. And it's a PDF I purchased, right? And you can buy a student version of it by signing up the student member, which we'll talk about it. But I want you to take a quick look at the content of this. So it has two parts, is the structure code and commentary, okay? On the left navigation panel, you'll see all these chapters, right? So for example, if we were to look at chapter 22, which is the sectional strengths, and you can take a look on the left are the codes, basic requirements, right? So we talked about this chapter has flexural strength, axial strength, one-way shear, two-way shear, torsion, bearing, shear frictions, and blah, 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 so on and so forth, right? On the right-hand side, the panel give you the commentary, basically the explanation of these content, okay? And this is a Bible for our field, especially when you go out there and design for companies, you will have it. It's mandatory, okay? So I suggest you buy it right now because it's going to be cheap for you to buy it. All you have to do is sign on as a student membership, then get a discount on it. I believe it costs you about $100 if you sign on the student membership. If you don't, it's going to cost you much more. Okay. Now we have a faculty discount, so it's also like $100, and I find it's very worthwhile to purchase. And one more thing is that for the exam, you need this code. So you can either use PDF or you can use the hard copy version. To me, the same. And for our exam, right now we set it online, but we will see the situation. If everybody is vaccinated before April, we might move the other two exams in person. So it depends how we're gonna situate, but you need to have a version or copy of ACI, okay? All right, so that's the two references. Then switching back, let's see, on the syllabus. For the course description, right? This course is designed to have you understand the mechanism of reinforced concrete structure. How does it work? Especially force pass system, how forces get transferred from one member to the other, and the stress distribution internally on the section. What is the stress distribution, and how do we design it for different members, right? For example, beam, slab, column, retaining wall and footings. We will not talk too much about retaining walls and footing. We'll focus more on beams, slabs, and columns, okay? And we'll talk about elastic and ultimate strength method. We'll talk about that in the class. And we introduce computer as design A2. Now, I have to warn us, the course is very well packed, too much information, right? Always too much information. So we may not have enough time to go to the computer aided design. But if we have, we'll probably introduce some of the SAP, like finite element design for you guys, okay? Now the prerequisite is structure analysis that you must take it already. If you haven't, it'll be surprised, let me know, we can work something out, okay? And the course objectives, right? we will learn the basic properties of concrete steel, and we'll learn the load paths from the different structures and the strengths and design methods for different members, sections, and all that, so on and so forth. We also learn how to calculate the strengths and design the members for it, especially for beam, for bending, and for shear, and also for concrete beam column joints, axial loading, and etc. And also, finally, the design of serviceability. Serviceability means deflection and the crack of the members. Okay, now you will find all these content from ACI code and from my notes, and we talk about what my notes normally look like, and you will have access to them through the canvas, right? If you take a look at the canvas right here, say I choose this class right here, and now on the left-hand side, right, this is syllabus, but you can click on file, right? If you click on files, you find all the information you need on my slow computer showing up here, right? So I have already uploaded the first 3 chapters of lecture 0, meaning introduction part of it. And they are in PowerPoint. They are in PowerPoint. And you have the YouTube link documents showing you where to watch the recorded videos and where to watch the online version of it. Well, it's kind of a chicken and egg, right? If you don't attend the first lecture and don't open the canvas, it'll be hard for you to find a YouTube link, but you guys are smart. I feel you guys should be able to figure it out. Okay, so that's the information where you can get access, where you can get access to the information at. And let's talk about the lecture notes. Okay, so first of all, let me share my screen. Okay, this is today. All right, this is today. We have some beautiful slides. We're going to go over quickly, talk about the basic introductions. Right, nice and easy. Right, you sit back and watch a movie and watch me yabba 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 and talk about information. Later, you go back and review them, which is pretty nice. Okay. However, though, this is not always the case. Matter of fact, this is not the case at all for most of the time, because in reality, what we're going to be dealing with is handwritten notes. Okay, handwritten notes. So this is a sample note from last semester and will be majority of the notes you're seeing from this lecture this semester. What will happen is I will use iPad and write notes on it. While I'm writing, you can copy it down and we'll upload it at the end of the lecture and you have access to them. But all these handwritten notes are going to be very important to your study, okay? So if you have iPad or you have a notepad, you can write them down. It would be great. You have a version, okay? And I oftentimes upload them to Canvas, but it's best that you follow my process, excuse me, every lecture so you have a better understanding of it, okay? All right, so that's that. And then let's get back to the syllabus. We haven't done that, finished that one yet. Where are we? All right, give me 1 second. I need to open it up again. So this is the syllabus. All right, here we go. Okay, here we go. So we're done with the notes and some of the course requirements, right? Lectures, it's not strictly reinforced since we're doing the online learning format, but I strongly recommend you watch all the recorded video at least, okay? And trust me, if you miss one, it's gonna take you a longer time to catch up. All right. Now, lab meeting, we talked about it, is mainly for lectures again. So we'll not do a whole lot of activities, but design maybe later in the class. Now, that will be decided, depends on the situation, on the various things, okay? And the class attendance, again, is not required now in person, but you're expected to watch the online version of it. Some of you say, I cannot attend the live session where you're holding it, but do let me know if you plan to always watch the recorded video. I need to know. And I do keep close an eye on monitoring attendance. And I want to see if you guys are getting the latest information or not, okay? So interaction is very important as well. Homework. Now, homework assignment will be due at the beginning of lecture. The day is due, okay? That is a very vague statement. The specificity is that we will release homework always, almost always on every Thursday of the week. And you expect to return it next Thursday, midnight, okay? So you have a whole week of time to finish the homework. We will normally post the homework with a due date on it. And if you submit it late, and automatically the computer will let me know you're submitting late, and sorry, there'll be discount, okay? Now, some ground rules. If you submit 1 day late, that's a 20% off. If you submit a 1 week off, 1 week late, that's 50% off. If over 2 weeks, I don't think you bother submitting it because you get 0 points. Okay, so that's roughly how late the homework tolerance is. Now exams, right? The best part. Now we have 3 exams: first midterm, second midterm, and final exam. Now I'm pretty sure the first midterm will be online, but I'm not sure about second and final yet. We may still hold in-person exam, depends on the situation, but we will let you know. Okay, we'll let you know. Now, ACI 3.18.19 code requirement, it is required to have a version of it. It is required to have a version of it. And the best way to go at it is that you want to go to register as a membership and get a copy of it. Now, I want you to take a look here. Required to have a hard copy of ACI 3.18.19. We have this rule from the past lectures. I think it's best to have a hard copy, but as it is now, it is okay for you to have an electronic version like I do right now for the exam. But I have to warn you, the electronic version is not that convenient. It has a login code and can only be used in one computers, so it cannot cross references. So it's not that convenient. In a way, is that a hard copy works the same as a soft copy, so it's up to you. Okay. Now, grading system, we have homework quizzes, takes about 40%, which is quite big. So you don't want to miss any homework quizzes, okay? 2 midterm exam, each midterm will give you 20% of weight percentage, okay? And the final is another 20%. Grading scale, we don't usually cut it off, okay? I've been teaching this for quite some time, and from my experience, this cutoff points are works very well. So sometimes we can even cut a bit lower, but not higher than that, okay? Now, one last piece of information, which is critical to you guys. Even if you got all hundreds, okay, in quizzes, in 2 midterms, but if you score less than 50% in the final, that's an automatic fail for you, okay? That's automatically a fail for you. So you don't want to do that, okay? You don't want to do that. All right, so make sure you pass all the exams. Make sure you pass all the exams. Let me go back to this somehow. Snap out of it. Okay. Now the rest you can read yourself. Students honesty. I don't think it'll be the case. Building egress. I don't think you have the problem. Title and all that. I think it'll be okay. Now, most important thing I want to go over at the final of the syllabus is the timeline, right? We'll start with introduction. We'll talk about chapter 1, which is the basic information about RC structures. We'll ease into the materials property or design. Matter of fact, we'll probably go to design first, then go to materials properties, and we'll go to specifics. Now, chapter 1, 2, 3, these 3 chapters will be in the form of PowerPoint where you can take a look at them, okay? But the rest of chapters, right, we have to go into written up notes where we get a lot of information. So, be prepared. We might go pretty fast on these ones, okay? All right, so from my previous experience, we most likely will finish at the columns. We're not going to the deck and column join so much because basically we just don't have the time. But if we have time, we might go into the retaining walls and the footings a little bit. It depends on the time, okay? Depends on the time. So that's all for the syllabus. All right, that's all for the syllabus. Okay, now finally, the course will be recorded, and I hope you can mute unless you have a question because it creates a strong echo to my lectures, and sometimes it get me distracted. So if you don't have any question, I strongly suggest you mute, and instead of me going into it and start muting everybody, okay? So that's the syllabus, all right? Okay, so now let's start with our lectures, okay? I want to start with introduction here. This is PowerPoint, okay? You find this again in the file folder. Now, welcome to RC Design, okay? This is the most exciting, to me, the most exciting structures in the whole civil engineering field, okay? If there's anything else that is maybe on the same level of excitement, it will be the steel structure, but I hope after this lecture today, you'll say that concrete is better, okay? Concrete is better, okay? Now, I want to take a quick look at the survey of the universe of buildings, right? Building universe. So you take a look at the chart, and this is updated 2018, but you can see that most of the buildings are 1 to 3 floors, 93%, and the 4 to 15 floors, mid-tier rise building is 6%, and high-rise building only have 1%, only have 1%. Okay, so that's what we're dealing with here, folks. I mean, we are not dealing with daily design of high-rise buildings, but mid-tier, low-rise buildings, okay? For the low-rise and mid-tier buildings, most used building types are concrete structures, All right, most used building types are concrete structures. That's why RC concrete design is very important. Okay, now it is very important. So we need to understand how to design our concrete buildings. The hundreds and hundred years of history of a concrete building design, we have learned one lesson that safety is priority number one. But on top of safety, now we're capable of designing a concrete building that costs less and more energy efficient. Okay, so we're going to talk about economical design perspective of the concrete buildings, All right. So first of all, let's take some general considerations. What are the three major components of concrete, right? So we know we have concrete, where you can see the mud and aggregates flowing through the dumpster and go into the wheelbarrow, and we can test them, we can pour them to form our structures. We also have our steel reinforcement, that is the rebar buried inside the concrete where we can reinforce it. And again, we also have formworks where we can form the concrete in shape. So these are the three major components and major cost item for the concrete structures. Okay. Now we all know that concrete reinforcement costs money, but seldomly we know that the formwork is actually very expensive as well. Right? To give you an description of how expensive it can be. Now, the labor cost to pour the concrete is much higher than the concrete itself. Now, 1 yard of concrete equals only to 2.5 hours of labor. Okay, so the average cost of concrete is about $120 and to $147 per cubic yard. Okay, and this is including the delivery 20 miles. But the cost of labor can go up to $45 per hour. We're talking about the folks of here, one guy, two guy, three guy, four or five, a five-man crew, and there's probably six right here. So we're talking about $45 multiplied by 6, and that's quite expensive, right? Per hour pouring. Okay, per hour pouring. And have this concrete pour usually costs about $2.5 to $2.6 per square foot for labor. And contrast the concrete is $2.83. So the labor is not cheap at all. Okay. Now on top of the labor, we'll also have the formworks. Right? So formworks depends on the sophistication of your structures. Sometimes can be very simple. We just have a block, we pour the slab, we pour the column. But sometimes we can be very complicated. So complicated we have to 3D print them. Okay. So up right image showing here, these are 3D printing the foam formworks. And these give us the complex shape we needed. All right. So a quick comparison here, a $2.6 per square foot of labor, $3 per square foot of concrete, and the formworks is $1, so it's not cheap at all. Okay, you got to figure that the formworks everywhere, right? It takes a lot of square footages because it's just all surfaces, right? So you have to take the formwork, economical side of formwork into the consideration of the design. Okay, so we plot a simple chart here. Vertical axis will be the cost and horizontal axis will be the complexity of the structures. So showing the two images here, two extremes. The left hand side is just a regular slab, precast slab, and we have very simple formulas, right? And if we have a complex shape, right? For example, like a artistic concrete or architectural structure concrete, we have to use a complex formulas, which we have to use 3D printing sometimes, which can be very costly, right? Which are very costly. So we prefer a repeatable size and shapes of concrete members for design, which probably the reason why concrete structures are normally a little bit ugly, simple. And we also strive for simple formwork so we can do fast constructions and cost less. Okay, to give you an example, here I want to show you how the cost increases with the complexity of the structure. For example, for the high-rise building, this is Torre Mayer Tower in the tallest building right now in South America. And as the building floor increases, right, the height of the floor increases, you start to have a lot of wind load and earthquake load, lateral forces, right? It might shake the building in a lateral direction. So in addition to the horizontal loading system, you need to have a lateral resistance to provide resistance for the lateral forces. We're talking about the frames, right, and the internal truss cores, and even we might have a damping isolation unit to resist the seismic loads. All these will increase the cost. So you have to keep in mind that simpler formwork is, less formwork you use, the better it is in terms of cost. Okay, so if we plot a figure here again with a cost versus structure complexity, and the blue line indicating the materials quantity, right? So as your structure getting more complex, for example, converting from a simple bulk of a concrete, a block of a concrete, to a artistic design of hollow structures of concrete, more efficient in structure sense, the materials quantity goes up and the cost, right, goes down, right? The cost goes down, takes less materials, that is, right? But the complexity in terms of formwork increases exponentially and labor increases. So the cost of forming increases exponentially, right? So there's a sweet spot where both has a relatively low point, and that is the optimal design we're shooting for structures, okay, for structures. All right, so for cost efficiencies, right, you start to realize that although we put safety as a priority, but under the hood, once safety is satisfied, we start looking at the cost. So we need to have optimized design, which means we need to reduce the floor system thicknesses and sometimes reduce the size of the structures, but also we want to consider simplifying the concrete formworks, okay? A faster, easier construction costs you less, right? Costs you less. All right. So another perspective why we think the concrete structure is good, right? Maybe even better than steel, is that offers scheduling opportunities. What happening is that you think of a structure steel as more like assembled structures, right? So you order the parts, you get them from the shop and put on the side and assemble them together to form a nice buildings. Once you have the structure, you start filling in, right? The fireproof system, the HVAC, right? And the cladding, the windows, that is, to give the structure the whole occupancy capability. But for reinforced concrete structure, you can do them simultaneously, right? That is, as you go floor, 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 one floor at a time, you can start building the interior of the structure at the same time, right? For example, if you're concrete casting the top floor, the third floor, you can start stuffing in the things, interior design components of the first and the second floor. So this gives you ample time, right? Save you a lot of time. So in terms of scheduling, actually the reinforced concrete structure is faster, okay? So let's go into the details of why. Normally, it is true, the concrete takes longer to build than steel. That is, though, if you have fresh out concrete and steel reinforcement, comparing to you have all the steel members at your hand and you can start assembling them, right? So no matter it's high rise and low rise, just at the building time for the superstructures, okay, for the superstructures, concrete is faster. Sorry, concrete is slower, right? Steel is faster. However, though, it's not that easy, right? It's not that simple. For concrete to get here, it's instantaneously, where we usually have the rebars available. We can order concrete from Roller Ready Mix, for example, and maybe an hour later, they can get you a truck and you have the concrete. But for steel, it's different. You need to design it for it. You need order, and nowadays most of our steel members come overseas, right? They need to do a shop design and they need to hard roll or cold roll them and fabricate them, make the connections. You see this Revit and these connections, and then ship them overseas and then ship it to the job site. So the waiting and the fabrication time takes for the steel materials add up, right? Eventually, the steel structures is taking as much time as the reinforced concrete, maybe longer, maybe longer. Okay, so these are added benefits of reinforced concrete structures. Okay, in a quick image is that if you do steel structures, you gotta do a whole structure and goes in and little bit by bit to finish an interior. But for reinforced concrete structure, you can do them simultaneously. So this significantly reduces the time. Okay, in addition to that, most of the concrete structures are usually fire resistant, have a 1 to 3 hour fire rating because the concrete cover, right? It covers the steel and concrete is more resistant to fire. Okay, of course it is function of thickness, so you have to design for it, but that's the advantage that reinforced concrete structure usually have. So in terms of finishings and cladding, which means windows and envelopes, the concrete structure takes less time. So it is actually faster for the reinforced concrete structures to be able to have occupancy, right? To be ready for people to move in, okay? So that is an important thing for reinforced concrete structures. So now, give you an overall view. If we take a look at the comparison between time takes for the concrete structures and compared to the steel, you see that for all the buildings, low rise, mid rise, high rise, the concrete structure is always the faster one. All right, always the faster one. So want you to keep in mind that the reinforced concrete structure is good because it's faster to build to have people move in, right? To move in ready. So that is critical. That is one critical aspects of it. Now, I want to maybe go back and correct my previous term about ugly, right? So normally we think about concrete, they're ugly structures, but not anymore, okay? We have been using concrete for beautiful structures because we have developed so many ways of utilizing it. For example, here, these are American Online Corporation campus Dulles, Virginia. And you can see that we have this exposed concrete surfaces where we don't have any decoration outside of it, right? This is the architectural concrete. And the beauty of that, it gives you a industrial feelings in terms of architectures, but also reflect lights, right? So give you a lot of lighting and give you a lot of optical feelings of the buildings. And back to a long time ago, people started using concrete structure for large span structures. Okay, so concrete does not represent small boxes, but can be representing open space as well. Open space as well. Okay, this is one of the oldest buildings by Augusta as well. Okay, so back then we can start seeing all this exposed concrete facade and large span structures. So directly utilize the concrete appearances for architectural design. And one of the most famous buildings here, Salk Institute, okay, by Louis Kahn, and all these are exposed concrete surfaces that give you a seriousness of feeling and nice facade. If you want to know more about it, there's a YouTube link right here, and you can click and upload of this PowerPoint again to the canvas. You can see it, okay? It's a lot of details involved into it. One of the modern design, my favorite is the Tato Endo's design. And this is one of the latest design in Chicago where they use the directly exposed the concrete inside. And you can see that this gives you a different modern feeling of the architecture. And you can see more from the YouTube video where they have actually a museum in St. Louis, right? You can go pay a visit if you're interested. So in short, right, I'm a structural engineer, so sorry for the architecture folks, but in short that concrete have a lot of good attributes, green attributes. The cast in place approach that allows to form the concrete slab system without any redundancy. So the structure joints look very aesthetically appealing, and also exposed to the surfaces allow the more convective radiant heat exchange, so it's more environmental friendly, meaning you lose less heat, right? Have a better insulation. And you have a lot of reflection through the indirect lighting, so you can reduce the cost in lighting. And especially it has a very good acoustic effect, means it can reflect sounds, can absorb sounds by the change of the surface textures. So in all, concrete has attracted more modern attentions in the design rather than steel structures. Okay, so you see more of a concrete structures. All right, so that is a aesthetic part of the concrete where we're all happy about. I want to dive in a little bit about the concrete floor system. So there are so many ways to design concrete structures, right? I just want to make a typical example. We can have a slab on column, slab and a cap on column, mat slab structure with column, one-way joist, and beam in slab and hybrid with column system. And this is a step-in slab with a column system. Okay, so it offers a lot of flexibility in making different various types of structures. And there are also a lot of construction methods achieve that. Before that, I want to show you some of the simple examples. And this is the parking structure buildings, right? Sorry, this is not. This is one of office buildings. But you can see that with the modern technology, we'll be able to make very thin concrete slabs. And this gives us a lot of flexibility in terms of occupancy room inside space and with a lot of simplicity in the structure design aspects of it. Okay, so these are more like a flat plate constructions. All right, and you see more in the parking lot structures where the height is critical. You want to have more vehicles and less flexibility of less deflection of the slab itself. So it gives you a lot of flexibilities in terms of buildings. Okay, we have this two-way slab column buildings. It's pretty simple to fabricate. Okay, it takes very less time. And again, we have old-fashioned pan job, right? Pan job are standard formworks can give you deck, end caps, diaphragm, and panes laid in a different direction, give you different designs. And typical pan job looks like this, right? You have the formwork joists going up and support your floor like this. Once all these are wood formworks, okay? These are temporary shore structures, right? They are not there permanently. And once you have that, we utilize this standard pan formworks, right? These are just steel plate, like a pan, right? Cooking pan. And you can use that to form the structure you need. And these are the end cap for the pans, right? So you can form them into the different sections. So you essentially erect these formworks and nail them on the floor joists to form the spacing you want for the diaphragms, and you simply just construct them and put them spaced out like that, right? So imagine the concrete is going to go in between the pans, on top of the pan to form the slab, in between the pans to form this more like a diaphragm, but beam like each member take care of the load. So that is a quick construction, right? So we can easily to form beam and slabs using this old method. And there are also other methods. For example, the lift slab constructions. You can see that these are basically the load-bearing columns, steel pipes inserted between all these concrete slabs, and we have the lifts, the hydraulic lifts on the top of it, and we lift the slab one by one to the corresponding height to form the floor system, floor system. Now we also have the side cast where you cast it and use the crane to lift it up, and supporting on the end of it is a typical tilt up construction. So it's also fast and have a good quality of casting control, and simple, and of course energy efficient, because all it needs just a crane, right? Just a crane. And if you want your building to build faster, even you can do prefab, right? Always can precast them in the factory shop. And nowadays we do that a lot for accelerated buildings, and have them like a component shipped on site and assemble there. Okay. So in store, we have a various, right, selection of different system. We can select the formwork correspondingly. We have a different way of constructing them. So essentially, we're saying is that we can do all kind of reinforced concrete structures. All right. But one thing we have to keep in mind that we always have the balanced optimal design and constructability, which means that we want a structure that is functional, aesthetically appealing, but also fast and cost less, right, to construct, okay? At the end of this, I want you to guys to take a look at ACI student e-membership, right? You need to sign up to get a discount on the ACI code. And like I said, ACI code is mandatory, so we will need it. All right? All right. Now, this is the first part of it. It's more like introduction. I want to pause a little bit to see if you guys have any questions for me, about the course and about the scheduling, anything. Anything for me, guys? Anything? Very quiet.
I just got a question.
Yeah,
Because well, I'm from Mexico City,
sure.
and I noticed that well, all buildings here in Mexico and houses are built of concrete. Uh, and then in the U.S., I can see most houses and everything is built of kind of wood. You just have the concrete foundation and wood. I was just wondering if that's because we are in a seismic area, or just because of the cost of labor.
Uh, that's a very good question, Sergio. First of all, it is more seismic related for sure. Sorry, it is not so seismic related for sure, because wood structures are not so bad in terms of seismic. Depends on the level of seismic loading. Okay, it is more due to the labor cost. Okay, but in terms of the seismic loading, it also depends on area. Maybe for specific areas, you need deep foundations, and you have a lot of like high level, high scale earthquake loading, where concrete structure is preferable. But I would say for residential buildings, supply and labor probably is a predominantly factors to have wood structures more popular in North America here.
Yeah, that's because you normally you don't. Well, I've never seen a house made of wood here in Mexico, and I was just wondering if it was because of labor, or it was just like we just like to make everything more expensive.
Well, I think the earthquake has a factor to it, but I will say that if you can make concrete structure because it's more costly that way, you should. But I don't think North America is situated for that type of design, though.
Yep.
Yeah,
Okay.
thank you.
Perfect.
That's a
Thank
very
you.
good question. Yeah, thank you. So anything
This
else, guys? Yeah,
this is just a comment about that last question.
sure.
I think that the thermal properties of concrete, I think that helps in the warmer climate of Mexico compared
Oh,
to
sure.
like the cooler in North America.
Yeah, that certainly is also the factor. Yes, thanks. Um, yes, but I have to add on to it is that we do have a good insulation system now, especially the foaming material for the wood residential buildings here in North America. So I think we can compensate that. So that is indeed maybe a concern there in Mexico. I don't know about environmental details, but like I just said, I feel like the residential building built here is probably as good as the concrete buildings in terms of energy efficiency.
I believe in the US is way more effective. 'Cause, I
Well,
mean, here you got nice structures here and all of that, and you have like, I mean, all those like insulating properties. But I don't know. I think we should start moving towards something like cheaper and like more like cost effective.
that's
But
right. That's right. I mean,
also,
I mean, does Mexico have a lot of big forestry? Because I think that United States probably has more lumber
well, Mexico,
available.
you have like all climates possible. In the north is desert. Right here in Mexico City, you have perfect weather, like all year round. You have like 40, like 50 to 70 degrees, and then you
Gotcha,
go
yeah.
towards the I mean to the bottom of Mexico, and it's just forest.
Right.
But
Well,
Mexico, yep.
yeah, I think we can probably spend more time on the topic, in the later section, because there are a lot to talk about in terms of energy efficiency. There's actually a hot area right now in terms of research as well. But let me say this way. Now, the RC concrete structures nowadays has a lot of good attributes, right? And I believe that only one downside right now I can see is the CO2 emission. So most of the research are trying to reduce that. But beside that, I mean, most of the reinforced concrete, I mean, you will see a lot of reinforced concrete structure in the modern constructions. Okay, probably the number of reinforced concrete structure in the cities are more in the urban, in the rural area, and you see a lot of modern buildings now in RC structures. Okay, I really liked the discussion. I enjoyed it. But is there any other question related to the course in terms of the question, the syllabus and the content, scheduling online format? Anything else, guys? Okay,
Real quick, I have a question.
sure.
On the code, the 318, 319 code book for applying for the membership for
Sure.
ACI,
Yeah.
could we use your email or should we use our actual advisor's email when it asks for that?
Oh, was it asking for the advisors?
Yeah,
You
professor or advisor.
sure, you can just put me down, no problem.
Okay.
Yeah, they won't bang me. I mean, they already may bang me, so that's okay. All right.
Okay.
Yeah.
Thank
I got a question about the homework, right? So it is usually released every Thursday, and it will be due the following Thursday. Have a week to work on it. Okay. Yeah. Due 1 week later. Thank you, Tyler. That's the right answer. Okay. All right. Anything else, guys? Anything else?
Are exams going to typically fall on Thursdays, or will they be on a
Yes.
different day of the week?
I try to schedule on Thursday afternoon so we have ample time for the exam. But if we schedule a different time, we'll let you know and we'll probably decide together.
Gotcha. Thank
Yeah.
you.
Sure, no problem.
Question.
Yeah.
So, should we get an online textbook and a paper copy, or should we just get an online textbook if we're an online student?
I'm sorry, your voice is a little bit broken there. Can you repeat your question, please?
So if we're an online student, should we just get an online textbook, or should we also get a paper copy textbook?
Okay, gotcha. Good question. So for the textbook, it is up to you entirely. You can use online or paper-based, that's fine. But for the code, I prefer you get a hard copy because A, I mean, you use it in exam. B, it carries you. I mean, you go everywhere. And electronic version, it is single computer use anyway. So it's not that convenient, meaning you have to carry a laptop with you if you want to use it. So for the code, ACI code, I prefer you guys have the hard copy.
Okay, thank you.
Yeah. Anything else, folks?
I understand that the lab section is just gonna
Right.
be like for quizzes, homework, and like exams.
A quick correction, Sergio. It's a good question, good comments. The lab session will mostly use for lectures. Okay. We'll have quizzes, but not specifically every Thursday. We'll have quizzes either Monday, Wednesday, or Thursday. That depends on the progress of the class. Okay. So Thursday just mainly for lectures. We use that for teaching basically.
Okay, perfect. So we're gonna have it every single week, right?
Yeah, we'll have it every single week, every Thursday, 1 o'clock starting.
All right, perfect.
Yeah.
Thank you.
All right, sure. Folks, anything else? Anything else? All right. Well, it is my first time to host such a large class online. Okay, I hold large class in person, and that's a different vibe. But I hope this online format will not hurt us in terms of interaction. So if you have any questions, feel free to email me, and we can schedule another meeting about it. Any problem with homework can be answered. Okay. One last thing before I let you go is that I want to introduce our TA, course TA. Okay. So where's my? Okay, here it is. Now, the course TA this is my research group website, and you can see all the folks here. And the course TA is this gentleman right here, Yan Xiao Li, or he goes by Shang, S-E-A-N, and he's in the Pine Box building, which is a small building next to our main building. And I will update his contact information. You can also find him from Canvas, okay? So he will be helping us to grade the homeworks. So if you have any grievances, talk to me and talk to him. We can try to address that, okay? All right. I'm very excited and very happy to have you all guys for this class. We have a lot of updated content for this course, and I hope all of us can have a great journey learning together. Okay. All right. So nothing else. I will close this lecture today, and can hope to see you guys Thursday. Okay, which is tomorrow, 1 o'clock, 1 p.m. afternoon. All right. Okay, guys. Have a nice day. See you guys later. Okay.